My name is Naoki Fukushi. Today I present my paper analyzing security risks of ad-based URL shortening services caused by users' behaviors. First, I would like to explain URL shortening services. URL shortening services make URLs shorter and simpler, which enables users to bypass character limits when posting to social media or improve the appearance of URLs themselves. For example, Twitter automatically shortens URLs in tweets, and there are also services like Bitly that allow users to shorten URLs. URL shortening services that generate income by displaying advertisement to users who access short URLs are called ad-based URL shortening services. Ad-based URL shortening services have some specific features which URL shortening services without ad do not have. These services display advertisement to users, reward short URL creators, and require additional user browser interaction. Here, I would like to explain an overview of the structures of ad-based URL shortening services. First, users access short URLs from referring pages, such as web pages posted on social media. Next, users reach intermediate pages that display advertisement. When users click on advertisement on intermediate pages, they reach third-party ad pages. The number of intermediate pages is one or more and varies depending on services. We refer to the final destinations of short URLs as destination pages. To reach destination pages or next intermediate pages, users need to click on buttons on intermediate pages. We refer to these buttons as genuine buttons. I explain intermediate pages in more detail. Intermediate pages have three main features. These pages do not make genuine buttons clickable immediately after their loading. Therefore, users have to do some browser interaction to make genuine buttons clickable. Also, these pages have lure buttons, which are advertisements that look like genuine buttons. So, users have to distinguish between genuine buttons and lure buttons. Furthermore, these pages may display CAPTCHA. CAPTCHA is a challenge response test to verify whether a responder is a human. Here, I explain the research goals of our study. The first goal is revealing security risks caused by users' behaviors to reach destination pages of ad-based short URLs. We consider two types of users' behaviors. One is when users click on only genuine buttons on intermediate pages. The other is when users mistakenly recognize and click on lure buttons that look like genuine buttons. Another research goal is understanding the strategy of ad-based URL shortening services to guide users' behaviors. For example, it is the structure from intermediate pages to destination pages. I would like to describe our proposed method. Our method detects genuine buttons on intermediate pages, focusing on HTML source code. Our method eliminates the need for us to distinguish between genuine buttons and lure buttons ourselves. Our method consists of three steps: activation, scoring, and detection. First, I describe the purpose and technical points of our method. Next, I will describe each step in more detail later. Here, I explain the purpose and technical points of our method. The purpose of our method is to distinguish between genuine buttons and lure buttons and support our analysis. At this time, lure buttons are not visually identifiable because they change their appearance every time we visit intermediate pages. So, our method detects genuine buttons without visual information. We focus on a common feature among advanced URL shortening services that HTML source codes change when genuine buttons become active. In the following slides, I will explain the 3 steps of our method to detect genuine buttons. First, I explain step 1. In step 1, our method activates a genuine button, which is not clickable or visible after an intermediate page is loaded. There are 2 conditions for activating genuine buttons: waiting for a few seconds or resolving capture. So, if capture exists on an intermediate page, our method highlights it by changing CSS style and we resolve it manually. If not, we wait for a certain second without any additional browser interaction. Besides, our method saves HTML source codes after intermediate pages are loaded for later comparison. Next, I explain step 2. In step 2, to select candidates of genuine buttons, our method scores each web element in the HTML source code of intermediate pages. Specifically, our method counts the number of predefined terms included in each web element. There are 2 categories of terms: the button category, which contains terms that describe buttons, and the click category, which contains terms that encourage users to click. For example, the lure button shown in this slide has a score of 0 because it does not contain any terms. And the genuine button in this slide has a score of 6 because it contains 6 terms. Finally, I explain step 3. In step 3, our method detects genuine buttons by using differences in HTML source codes. Our method uses the features that when a non-existent or non-clickable genuine button becomes active, there should be a difference in the source code of the intermediate page. First, our method compares step 3 current source code and step 1 source code, which is saved immediately after an intermediate page is loaded, and extracts differences. Next, our method finds the union of these differences and the genuine button candidates. Here, genuine button candidates are the web elements with a score of 2 or higher. Finally, our method detects and highlights the one with the highest score in the union as the genuine button, and we clicked it manually. Here, I describe the measurement study we conducted. We selected 30 advanced URL shortening services that are heavily accessed by users, and created one short URL from each service. We found that the structures from intermediate pages to destination pages, such as the number of intermediate pages, were always the same regardless of the destination pages. So, it is enough to investigate one short URL for each service. We accessed these 30 short URLs and reached destination pages. We conducted 2 experiments. One in which we clicked on only genuine buttons detected by our method, and another in which we clicked on lure buttons in addition to the genuine buttons. Besides, we changed regions of our source IP addresses using a VPN service to consider that displayed advertisements vary by region of users. We monitored web requests between accessing short URLs and reaching destination pages. By doing this, we investigated whether there is a security risk of reaching malicious web pages. First, we discussed the result of the evaluation of our method. We evaluated whether the buttons detected by our method were the correct genuine buttons or not, Specifically, we accessed a total of 30 short URLs and could reach destination pages by clicking on the detected buttons. If the detected buttons were not genuine, we could not reach the destination pages. Therefore, this result shows that our method could correctly detect all the genuine buttons. Our method takes advantage of a common feature among ad-based URL shortening services. The source code changes when the genuine button is activated. Therefore, we can say that our proposed method will work with versatility even when new ad-based URL shortening services are created in the future. We investigated the number of intermediate pages that users need to go through before reaching destination pages. We show the result in the table. We found that 25 out of 30 services had more than one intermediate page. This is a mechanism to increase the time spent on intermediate pages of users and increase their advertisement click rate. And we revealed that a total of 55 genuine buttons required waiting for some time or resolving captcha. Here, 24 services required captcha resolution. Ad-based URL shortening services investigated in previous studies did not require captcha resolution to activate the genuine buttons. Thus, the structure of intermediate pages of the latest ad-based URL shortening services has changed compared with those investigated in previous studies. We revealed the security risks when clicking on only the genuine buttons. As a result, 688 malicious domain names were detected between all services. These malicious domain names were loaded in the main content, iframe tag, and script tag. We found that all services generate an average of 86.5 web requests to malicious domain names per short URL. Also, we checked the screenshots of reached malicious web pages. We revealed that these malicious web pages were mainly registration pages for scam services and web pages that ask users to allow malicious web push notifications. These results showed that even if users click on only genuine buttons, communications to malicious domain names may occur. These are screenshots of malicious web pages that users may reach. These malicious web pages attempt to steal personal and credit card information or deliver malicious web push notifications. Besides, we revealed the security risks when clicking on lure buttons. We manually selected advertisement as lure buttons that users might misidentify as genuine buttons. As a result, 15 services displayed lure buttons on their intermediate pages. The average number of displayed lure buttons was 2.9. And we clicked all the displayed lure buttons and monitored web requests. The average number of malicious domain names loaded in the main content was 4.2. Advertisers display lure buttons to encourage users to click them and receive advertising revenue. However, our results showed that when users mistakenly click on these lure buttons believing that they are genuine buttons, the risk of users communicating with malicious domain names will increase more than when users click on only genuine buttons. We conducted our experiments from IP addresses in 6 regions by using a VPN service. The average number of malicious domain names detected in each region was 410.5. The highest number was 442 in Brazil, and the lowest was 378 in Japan. Also, we investigated the number of regions in which each domain name was detected. The largest number of regions in which each domain name was detected was 6, and the second largest was 1. accounting for about 73% of the total. This result shows that there are malicious domain names that are specific to users' regions and independent of users' regions. For users to reduce such security risks we revealed, they may install ad blockers on their browsers to filter out communications to advertising domain names. On the other hand, anti-ad blocking is a common tactic for site owners against ad blockers. We chose two of the leading ad blockers, AdBlock and AdBlock Plus, and investigated whether we could reach the destination pages when we used a web browser with these ad blockers. As a result, we were unable to reach the destination pages in 19 services with AdBlock and 18 cases with AdBlock Plus. As shown at the bottom of this slide, these services with anti-ad blocking features showed warning messages asking to disable ad blockers, and chaining buttons were hidden. This result shows that it is difficult to use ad-based URL shortening services and ad blockers at the same time to reduce security risks related to malicious advertisements. Next, I would like to make the following recommendations for each stakeholder based on the results of our measurement. We showed that if a user only clicks on chaining buttons to reach the destination page without clicking on any of the displayed advertisement or lure buttons, he or she may reach malicious web pages. Therefore, for users, we recommend to be aware of the security risks and not access ad-based short URLs carelessly. For ad-based URL shortening services, we recommend that they don't create multiple intermediate pages. In that case, the number of genuine buttons that users need to click on will be 1. Reducing the number of opportunities for users to select and click genuine buttons could reduce the security risks of reaching malicious web pages. For advertising providers, we recommend that they should not display misleading advertisements. We consider that users should be able to easily distinguish between advertisement and genuine buttons. Finally, I would like to conclude this study. In this study, we comprehensively investigated the latest ad-based URL shortening services. For our analysis, we proposed a method to detect genuine buttons on intermediate pages, and this method could detect all the genuine buttons of ad-based URL shortening services we investigated. And we revealed the security risks of ad-based URL shortening services caused by users' browser behaviors. We found that even if a user clicks on only genuine buttons to reach destination pages, there is a risk of reaching malicious web pages. With this, I would like to conclude my presentation and thank you for your attention.